Hi, I'm Mallory Avila, and our group picked multiplying whole numbers.
My name is John Valadeo.
And I'm Brenda Reyes.
So our standard is a fourth grade standard, and it says that students will be able to interpret a multiplication equation as a comparison. So for example, this means if we're looking at 7 times 5 equals 35, we could look at it as 7 groups of 5 or 5 groups of 7. Students will also be able to represent multiplication problems verbally and throughout word problems.
So our definitions and key phrases for this lesson. Multiplicative comparison means you are comparing two things together that need to be multiplied. We use the two statements to determine the number sentence or equation. An equation is just like a number sentence, but it includes letters. And our key phrases include times as many, times more, and times as much.
And then for our growth mindset, we want students to do I can statements. So we want them to believe in themselves. So the two I can statements are I can explain how a multiplication equation can be interpreted as a comparison, such as Howie ran 5 times as many laps as Brenda. Our second I can statement is I can write an equation for a situation involving multiplicative comparison.
And some common misconceptions when it comes to multiplication. The idea that multiplication it makes bigger is one frequent math misconception that appears in educational settings. However, it doesn't always. Our second one, multiplying by a negative number makes a smaller number. This isn't always true simply because you can have a number like 2 times -4, and it's going to be equaling -8. It doesn't always mean it's smaller. It technically can get bigger. Learners do not understand lots of or groups of. Students see it as a test of their memory. Splitting up multiplication into lots of and groups of is very good just because it makes it easier for visual learner students instead of those who are just learn by watching someone do problems. Ways to prevent these misconceptions using the area model. It supports students' understanding and reasoning in multiplication. Like I said previously, it helps for visual and hands-on learners. And then partial product, students record their products and add using column sheets. Writing down all of your results on paper is most beneficial when it comes to multiplication, especially if you need to have evidence for all of your problems.
So we're breaking our lesson up in 3 days, and for day one, we want to introduce it as a visual representation. So right here's an example. How can we write 7 times as many as 4 as a multiplication equation? So you have 7 groups of 4. So right here you have 1, 2, 3, 4, 5, 6, 7, 7 groups, and in each group there are 4. So 7 times 4 equals 28. They could, if they didn't know, they could either make tally marks or they can add up all the 4s and they would equal 28. So for this visual representation, we are going to highlight math practice 2, which is reason abstractly and quantitatively. We really want them to think about math. Students can think about words, numbers, and symbols to solve problems. So this visual representation allows them to see words, numbers, and symbols in order to solve the final equation. So going back to the visual representation, right here we have the same math problem as 7 times 4, but this is a better visual so the kids can see instead of a number 4, they can see tally marks. That way they can physically count each line and they can get their answer. So you have 7 groups and there are 4 in each group. If you count all the lines together, you would get 28. So for our guided practice of day one, we want to start off easy. That way they can be confident. So we set this up as 6 times 5. We already have the 6 groups. So they would have to figure out how many tally marks go in the 6 of these circles. So they can work individually in pairs or groups. That way they can build confidence and be sure that they are, on the right track. So after they go over it together individually or in a group, we would then, as a teacher, go over the correct answer and then answer any questions about any misconceptions or what went wrong or what did go right. And then we want to make sure they get good practice. So another one would be 8 times 3. It would be the same model. We draw the 8 circles, and then they would have to figure out how many tally marks go in each group. And then same thing as the previous one, group work, individual or partner, and then go over each other's work to make sure that it's all correct. When you count up your tally marks, 8 times 3 equals 24. So after they get the hang of these two, or of this one visual representation, we're gonna go ahead and go with our model with mathematics. So we want students to show their work in many different ways. So we already went over this first one with our groups and our tally marks. So 6 times 3, you would get 18 by counting all your tally marks. But another way the students can learn is by using this bar model. So you have one group of 6. If you create 3 of those groups of 6, how many would you have? So you count 1, 2, 3, 4, 5, 6. This is one group. This is your second group and your third group. So when you count them all together, you get 18. And this is a different way for them to visually see it if they prefer this method. And then another method that we want to introduce to the students are word problems. So you have a statement, a question, and an equation. So you first start off with your statement as John made 3 pies. Mallory made 6 times more pies than John. And then times more goes back to our key phrases. That way they know all these words mean multiplication. So our question is, how many pies did Mallory make? So if John made 3 pies and Mallory made 6 times more, you would multiply these together and you would get 18. You're
Group work,
muted.
group work for day one. Students will get in their groups of 4 or however many are at their table, and we will put these 5 questions up on the board, and students will have to choose 3 to solve using either the circle method or the bar method. They will be expected to show their work and be able to explain why they did what they did.
All right, and then for our exit ticket for day one, the students will be required to create their own multiplication problem and show it visually, whether that is with groups of or bar graph. Like we said in the previous slide, they will be doing group work, so they will get ideas from one another and they will touch up on the method that they're not best at. So they could possibly use it for their exit ticket. All they'll need to do is get their own piece of paper and submit that before we can move on to the next lesson.
Okay, so day 2 is going to focus more in on word problems. So this example will be shown to the class. It's just the first to kind of introduce the students to it, let them ask their questions, just to get them familiar with the concept. So this problem says 2 football teams met at the park to play a game. Each team brought 4 balls. How many footballs are at the park? So we know that the 2 numbers being multiplied are 2 and 4. We know this because there are 2 teams and both teams brought 4 balls. So we know that we're gonna have 2 groups and each group is gonna have 4 in them. That's where we get our 2 times 4. I didn't want to solve this one, so students could use the past bar or circle method to solve this. We just wanted to help them understand the layout of the word problem, how to create their own, and how to read it and understand it. Using this method allows students learning multiplication to break down the problem and make it more simple to solve. Group work for day 2. 5 problems will be projected onto the board. And instead of doing 3, students will have to do 2, and they will have to make word problems that go along with these equations. And not only will they have to make the word problems, they'll have to solve them using the bar or circle method.
And then that way we also promote collaboration, but also set them on the right track to get guided practice, but among the students. For individual work day 2, students will create their own word problem following this statement that they learned on the first day. So our statement was John made 3 pies. Mallory made 6 times more pies as John. So they can change the pies and the names to anything that they would like, including the numbers. That's the big one. We want them to get more practice with the numbers. So our question is, how many pies did Mallory make, or whatever the students choose to replace pies with? And the equation is what they have to figure out and solve. But But the collaboration part on this slide is next students will get up and walk around to find a new classmate. They're going to switch papers and solve each other's problems individually. And then once they figure it out, they're going to switch back to make sure that their partner did it correctly.
Then for our exit ticket for day 2, students will be required to create their own word problem for a multiplication problem, but they cannot use the same numbers they used in the previous exit ticket. The reason being for that is because if they use the same numbers from the previous day, they're just touching up on what they already know, but instead we want our students to kind of challenge themselves and put themselves out there when it comes to multiplication and just trying to spread their wings and work on bigger problems. So yeah, they'll have to create their own word problem, and then for the exit ticket for day 3, we'll bring them 2 together.
And then day 3, fun with numbers and visuals. This is going to be combining what we learned in day 1 and day 2. We're going to be taking the visual solving of the multiplication problems and mixing it with their own word problem. And I have a couple examples here that we would show the class. No answers. The students will have to just solve this as review, and then we'll have some where they have to make their own word problem and solve. So this one says, John and Dylan love cookies. John ate 2 cookies and Dylan ate 8 times as many cookies as John. How many cookies did Dylan eat? So right here we can see that John ate 2, Dylan ate 8 times as more. And then just to follow along with the bar method from day 1, we briefly touched on it. This goes a little bit more deeper into it. But John, we have the 2 groups for John, and then we know we have to do this 8 more times. So we're going to have 8 groups of 2. And then as previously stated, to find our answer, we can just count up all of these, boxes, and then it'll give our students their answer. This is just another example of the same thing, word problem, bar model. This one says, Brenda and Howie are running laps around the track. Brenda ran 4 laps and Howie ran 5 times as many laps as Brenda. How many laps did Howie run? So this one we probably won't explain as much. Students will be able to figure this out either with their groups, individually, however, but this one will be reviewed with the whole class. Questions can be asked. And yeah. Group work for day 3, students will get in their groups and create their own word problems along with a visual representation to go along with it. They will be provided markers and poster boards to write on. They will be given a certain amount of time to complete this little presentation, and then after time is up, each group will present their problem in front of the class.
And then to wrap up our 3-day lesson, students will need to turn in a piece of paper with both a word problem and a visual representation of a multiplication problem. Again, they need to use different numbers than they have previously used and cannot use word problems that a group previously has presented. In the previous slide, we said that they're going to be presenting in front of the class. So we don't want them to go ahead and write on a piece of paper what they already saw. We want them to try something new because in that case, it's not really an exit ticket. It's not really an evaluation of what they have learned from the past 3 days. So that pretty much concludes our lesson plan presentation. We hope you guys learned something new from this.
Thank you.
Thank you.